Teacher Nev, and welcome back to our general math class. We've discussed in detail the properties of the graph of different exponential functions in the previous video lesson. This time, we will focus on one of those properties, the domain and the range of an exponential function. Let us have a quick review of what domain and range are. Domain is the set of x values or the set of values of the independent variable. On the other hand, range is the set of y values or the set of values of the dependent variable. Since there is a dependence relationship between x and y, it is good to take note that we obtain the values of y from the values of x.
Example 1. Determine the domain and range of f of x equals 2 to the x and f of x equals 3 to the x. To know the set of x values and the set of y values for each of these two equations, we need to prepare a table of values for each. We have learned in a previous lesson that this is the table of values for f of x equals 2 to the x, and this is the table of values for f of x equals 3 to the x. From the table, we can see that x may take any real number, and even from the equation, we can deduce that since x acts as an exponent, it may take any number, a negative, zero, or positive, a whole number, an integer, or even a fraction. So that means the set of x or domain for each of these functions is the set of real numbers. For the range, from the table, we can see that all are positive numbers. It can be fraction or integer. To the left, we can see that the y values slowly decrease and gets closer and closer to 0, but it will never reach 0 or any negative number. To the right, we can see that there is a fast increase, a rapid increase. So that means that the range or set of y values is the set of all positive real numbers. That is true even to f of x equals 3 to the x. These are the graphs of the given functions in example 1. The green curve is for f of x equals 2 to the x, and the purple curve is for f of x equals 3 to the x. They share the same properties. By merely looking at their graphs, we can see that the domain of each is the set of real numbers because the graphs will, or each of the graphs will decrease to the left continuously and increase infinitely to the right. So x may take any value. So that means the domain is the set of real numbers. And for y, so that refers to the numbers here on the vertical axis, we can see that the graphs does not touch or pass through the x-axis, so it cannot be negative. There will be no part of the graph in the third quadrant. So that means that the y values can only take positive numbers. It cannot be 0 nor any negative number. So the range is the set of positive real numbers. Again, given f of x equals b to the x where b is greater than 1, take note that each is written in this form. The domain is the set of x values such that x is an element of real numbers. So this is how we write it in set notation. And in interval notation, this can be written this way. The domain is from negative infinity to positive infinity because the x may take any value. For negative numbers, it will decrease infinitely to the left and it will increase infinitely also to the right. And for the range, in set notation, it is the set of y values such that y is greater than 0, to mean that the y is a positive number and that y is an element of real numbers. We need to specify this also to tell that y can be an integer or a fraction. And in interval notation, it is written this way. The range is 0 exclusive. That's why we have the open parenthesis, meaning it cannot be 0. And then up to positive infinity. Example 2. Determine the domain and range of f of x equals 2 to the x and f of x equals 2 to the negative x, or f of x equals 1/2 raised to the x. So these two equations refer to the same function. Okay, in the previous lesson, we have learned that this is the table of values for the first given equation, and for the second, this is the table of values. Again, since x acts as an exponent in each of the equations, we know that it may take any integer, fraction, negative, zero, or positive number. And we can see that from the table of values. X takes any number, so it is a set of real numbers. That's the domain. For the group of y values, so all are positive, increasing again. And for the second equation, is the other way around. It is decreasing. So let's see it in graphs. These are the graphs of the two equations. The green curve is for f of x equals 2 to the x. The purple curve is for f of x equals 2 to the negative x, or it can be expressed also or written in f of x equals 1/2 raised to the x. Okay, from their graphs, let's focus on the purple curve because we have already discussed or described the graphs of f of x equals 2 to the x. So when x becomes negative, or when b is between 0 and 1, like this one, 1/2, the graph looks like this. Still, x may take any value, so the domain is still the set of real numbers, and still y is the set of positive real numbers because it does not touch the x-axis, so y cannot be 0 nor any negative number. Let us review. Given f of x equals b to the x, where 0 or where b is greater than 0 but less than 1, the domain is still the set of x values such that x is an element of real numbers in set notation. And in interval notation, that is, the domain is from negative infinity to positive infinity. And then for the range, again, it is the set of y values where y is greater than 0 and y is an element of real numbers. And in interval notation, that is, the range is from 0 exclusive to positive infinity. Example 3. Determine the domain and range of f of x equals 2 to the x and f of x equals negative 2 to the x. So take note that both values of b are 2, positive 2. However, they differ in a values. A here is positive 1 and a here is negative 1. So this means that the base is 2 only. The base of the exponent x is 2 only, not negative 2. So you raise 2 to the x first before you multiply them by negative 1. And you'll get the value of f of x. Now, this is the table of values for the first equation. And for the second one, this is the table of values. So again, since x acts as an exponent, then we may expect and we are sure that the domain is the set of real numbers, and we can see that from the table of values. However, for y, we can see that for the first equation, it's positive numbers. They are all positive numbers. However, for the second equation, we can see negative numbers because after finding the value of 2 to the x, you will multiply it by negative 1. So for sure, that will be negative. And let us see them in Cartesian plane. So these are the graphs of the two equations when a is positive and when a is negative. So they are symmetric with respect to the x-axis. We have learned that already in the previous lesson. Again, this is the graph of our standard equation, f of x, that we are using since example 1, from example 1. And then when we make it's a negative, it will look like this, the purple curve. So what will be affected, the domain or the range? The domain is still the set of real numbers because x may take any value from negative to positive number. However, what will be the y values? Instead of positive, it becomes negative now. So how will we express that in set notation and in interval notation? So given that f of x equals a times b to the x, where a is negative or less than 0, the domain is still x, set of x values such that x is an element of real numbers. So this is how you write it in set notation, and in interval notation, that's from negative infinity to positive infinity. For the range, it's the set of y values such that y is less than 0, meaning negative. So from positive, it becomes negative. It cannot be 0. It must be less than 0. And y is an element of real numbers to specify that the group of numbers which are less than 0 are not just integers but also fractions, those numbers between integers. And in interval notation, that is written this way: the range is from negative infinity to 0 exclusive. So the value of a affects the range but not the domain. From positive, the range becomes the set of negative real numbers. Example 4. Determine the domain and range of f of x equals 2 to the x, f of x equals 1/2 times 2 to the x, and f of x equals 2 times 2 to the x. So notice that all b's are 2, positive 2. However, they differ in a values. The first is positive 1, second is 1/2, third is 2. So still all are positives, but let us see how the different values of a will affect the graphs or the domain and the range particularly. So this is the table of values for the first equation, the second equation, and for the third equation or function. So still, by merely looking at it, the domain is still the set of real numbers. How about for y? It's still the set of positive numbers, but let us see if they are set of real numbers or if there will be restrictions. So these are their graphs. The green is for the equation for the function that we've been using since from example 1. The blue curve is for f of x equals 2 times 2 to the x, or when a is 2. And the purple is when a is 1/2, that's less than 1. What do you notice? So the blue curve or the graph of an equation where a is equal to 2, positive 2, is shifted to the left. However, the graph of the equation with a equals 1/2, that's less than 1, is shifted to the right. So this is greater than 1, a equals 1, and this is less than a equals 1. But we can see that the domain, that x may take any value to the left, to the right. So maybe it's a set of real numbers, and the y values can only be positive. All do not touch the x axis, or y is not equal to 0. So that is given f of x equals a times b to the x, where a is positive or greater than 0, the domain is still the set of x values such that x is an element of real numbers, and in interval notation, that's negative infinity to positive infinity. Then for the range, it is the set of y values such that y is greater than 0, so all positive numbers, and y is an element of real numbers, so all positive real numbers. Or in interval notation, that's from 0 exclusive to positive infinity. So the value of a does not affect the domain and the range. Example 5. Determine the domain and range of f of x equals 2 to the x. F of x equals the binomial 2 to the x minus 1, and f of x equals 2 to the x plus 1. Notice that the values of b in the three equations are all 2. However, they differ in d values. Here, the d is 0, so that this comes from plus or minus 0. Here, for the second function, d is equal to negative 1, and d is positive 1 or 1 in the third function. So let us look at their table of functions, table of values. This is the table of values for the first, for the second function, and for the third. By merely looking at their table of values, we can see that x may take any value, so it's the set of real numbers. That's for the domain. And for the range or set of y values, look at the second rows. We can see positive and negative numbers. We also have here integers and fractions. So let us visualize them, or let us take a look at their visual representation in the next slide. So this is how their graphs will look like. This is the graph of the first equation. We have been seeing this from example 1. So f of x equals 2 to the x. It's increasing. And the other two are also increasing. And x may take any value. So the value of d does not affect the domain. How about the range? We have here negative. When d is 0, then it is shifted upward by 1 unit when d is equal to 1. So that means the value of d determines the shift. So it is shifted 1 unit upward every point. Every point here is shifted 1 unit upward. That is determined by the value of d. And when d is negative 1, every point in the green curve is shifted 1 unit downward because that's negative 1. So we can expect that if this is negative 2, every point in this curve will be shifted 2 units to the or downward. So that means the value of d affects the range. Let us generalize it. Given f of x equals b to the x plus d, the domain is still the set of real numbers, or x, such that x is an element of real numbers. And this is again how we write it in set notation and in interval notation, from negative infinity to positive infinity. That's the domain. For the range, in set notation, it is y such that y is greater than d. So any value of d. The set of y values is always greater than the value of d. When d is negative 1, so it must be greater than negative 1. It cannot be exactly negative 1 because this line acts as an asymptote. So it is always y is greater than d, and y is an element of real numbers. And in interval notation, that is d exclusive to positive infinity. Example 6. Determine the domain and range of f of x equals 2 to the x, f of x equals 2 to the x minus 1, and f of x equals 2 to the x plus 1 power. So the value of b in each equation is 2. However, they have different c values. Here, this is x plus or minus 0, so the value of c is 0. Here, the value of c is positive 1 because this comes from x minus c. And again from x minus c, so the value of c is negative 1. Let us see how the value of c will affect the domain and range. This is the table of values for the first, for the second, and for the third function. So x is the set of real numbers as we know, and the y, we can see positive numbers. It can be a fraction, or an integer. So let's visualize them in a Cartesian plane. These are the graphs of the three functions in example 6. The green is, of course, for our f of x equals 2 to the x. The blue is when the value of c is negative 1. And the purple is when the value of c is positive 1. When it is negative 1, it is to the left of 2 to the x, or when c is 0. And if it is positive 1, it is to the right of c equals 0. Given f of x equals b to the x minus c, the domain is still the set of x values such that x is an element of real numbers. And you can see that from the graph. It may take any value. So that's in set notation. For interval notation, of course, it is from negative infinity to positive infinity. Now, for the range in set notation, still y such that y is greater than 0 and y is an element of real numbers, because it takes any positive number, although it is shifted to the left or to the right, still they take positive real numbers for y, and they cannot be 0 or any negative number. So this is still the range. Or in interval notation, that is 0 exclusive to positive infinity. So that means the value of c does not affect the domain and the range.
Let's generalize it. The domain of an exponential function is the set of real numbers. The range is the set of positive real numbers except for cases where a in f of x equals a times b to the x is negative. The range in this case is the set of negative real numbers, and except also for cases where d is not equal to 0 in f of x equals b to the x plus b. The range in this case is all real numbers greater than the value of b. Until next time,